Hello, Mrs. War here, again, to go over Check for Understanding 5.3. So, like I've said in the other videos, you may want to turn the speed on to double time so that you can make it through these solutions videos quicker. I would try to listen to the feedback for each problem, just in case there's something that you can add. And then lastly, I haven't said this in the other videos, but I should say it, you're absolutely welcome to and should use these solutions to correct your assignments before you turn them in. That being said, I would very strongly, as strongly as I can, encourage you to really do these problems before you go through the solutions. I mentioned in another video that I really think posting the solutions last year for the students hindered their ability to be successful. Now you guys are by and far a much better set of students than my students were last year. But even my best students, like my best student last year, I was sure was going to get a 5 and ended up getting a 1. So I think part of that is always having access to the solutions makes it so that you don't push yourself as hard to try to get these problems done. So please, before you watch the solutions, you really need to try these on your own. So most of this is describing distributions, and our descriptions are going to be different. That's the nature of writing. We're very rarely going to write the exact same thing. So you just need to make sure on your descriptions that you are hitting your SUCS acronym. So you're discussing shape, and our shapes need to be the same. You're discussing unusual features. Then where things differ a lot is how you describe median and how you describe spread. There's different ways that you can do that. So as long as what you're saying is accurate, then you're fine if yours is different from mine. If you are concerned that your descriptions will not receive full credit, I would take pictures of the ones that you're concerned about and send them to me before we're together again on Monday so that I can read over them and tell you concretely, like, yes, you're on the right track, or no, you would not get full credit for this. So if you think that you're on the right track but you're unsure, send it to me. Otherwise, make sure that your answers align pretty closely with mine. The 4th grade agility test, I have that it's right skewed with an outlier in the interval 50 to 54. The median of the distribution is between 20 and 24, so students typically clear between 20 and 24 lines. One thing that is really important is that you state the median so that it's clear to your grader that you know the reason that you care about median is because it describes the typical observation. The number of lines cleared varies from as low as 10 to as high as 54, with most of the students clearing between 50 and 30 lines. I talked about this one way more in depth on the hints video that I gave for this one, so I'm not really going to go much beyond what's here. Textbooks. The distribution of money spent on textbooks is right skewed with a gap from 62 to 81 and no outliers. The median, and I actually calculated that. You will see right here because they gave me the entire distribution that I went through and calculated mathematically if there are outliers. So when I say no outliers here, my grader knows I actually did my due diligence and checked it. The median of the distribution is $28.50, so these students typically spent about $28.50 on textbooks. So you not only need to state the median, but you also must give the context that you know why you even care about what the median value is. The amount of money spent varies from 12 to 81 with an IQR of $39. I chose IQR because I could calculate it and it's skewed, So that's what they're most interested in for spread. Here, I did not use IQR because IQR, describing that when you're working with a histogram, is very messy. So I just say most of the data is within this range. Your room size, the distribution of room size in the residence hall, and I'm sure this differs from the key that you guys have seen. And I'm 100% confident that the key that I showed you and this response, they will both receive full credit. So if it's different, don't let it worry you. The distribution of room size in the residence hall is symmetric and bimodal with no outliers. The median may be as low as 200 and as high as 250, but there appears to be two distinct groups in the distribution. So 2 to 250 does not accurately describe the typical room size. Room sizes vary from 100 to 350 square feet, with a clear group on the lower end and another group on the upper end. So you could have said, there appears to be two distinct groups in the distribution, one from 1 to 200 and the other from 250 to 350. So I don't think the median describes the typical room size, and that's totally fine. The order doesn't matter as long as you're getting all of the information in. Amount of money spent on plane tickets, the distribution is roughly symmetric and unimodal with no outliers. The median may be as low as 400 and as high as $599.99. So these students typically spent between $400 and $600 to get home. The amount spent varies from 0 to $1,200. I did not give a range because it seems stupid. If the amount spent varies from 0 to $1,200, then it seems redundant to me to say, so the range is 1,200. So I just left it as how it varies. If you wrote the range, that's fine. Don't erase it. I just didn't put it because I felt like this was explicit enough. Okay, multiple choice. 5 is beta. 6 troubled me for a minute, but it's delta. The frequencies, the sum of the frequencies always has to remain the same. If you change your bin size, it doesn't change your number of observations. But if you change your bin size, it could change the way the data looks. And I don't think I included it on this. Oh, I did. So if you look at this one, the shape of the data, it looks different in each of these graphs. Like this one, I remember telling you, this probably is not a great bin size because you can't really see the shape. But once I break it down to like these bottom three, the shape is looking roughly symmetric, but this outlier makes it right skewed. So it's not necessarily that the shape is changing, but the bin size can give you a better picture of what the data looks like, and you can choose bin sizes that just make your distribution look like 2 bars, or you can spread out those bins and really start to see a right skewed or a left skewed shape. 72, house prices are typically skewed right. So anything that has to do with money is typically skewed right. So average income, house prices, car prices, anything having to deal with money is typically right skewed. So what you're seeing here is that they're telling you most houses are 200,000 to 500,000, so that's like this shape. But then you have some all the way out here at 15 million, so that's making this shape right skewed. Caffeine content. Last year when I did this key, I concluded that this distribution is roughly symmetric. But one of my students responded that they thought that it was bimodal, and I agree with them. The more practice I get with describing distributions, the better I get at it. So I personally think that this shape of this distribution is bimodal. We split the stems so that we can see the shape of the distribution better. I'm not sure that you would see that there's 2 peaks unless you split the stems. One thing I don't like about this, though, is that I do think that there should be another 1. I don't like that they left that lower stem off, but we split the stems to see the shape and the features better. When you give your key, make sure that you are adding context. So the context here is that it's 26 or whatever number you used milligrams of caffeine. And then my description, the distribution of caffeine is bimodal with a peak in the upper 20s and another peak in the upper 30s. The distribution does not have any outliers, and the reason I'm saying that without calculating it is because there is no gap in the data. I really only want to look at outliers if there's a strong skew, but even then, it'd be hard to, I shouldn't say it would be hard. Even if there's a strong skew, if there's no gap in that skew, then that probably isn't an outlier. So, I always check if it's an outlier if I see a gap, which is why on this problem on the front page, I really checked to see if there was an outlier because this does have a gap in the data, and I mentioned the gap. So, I did not calculate whether or not mathematically calculate outliers because there was no gap. So, I think that there's no outliers. The median of the distribution is 28 milligrams, but I don't think it accurately describes the typical caffeine content because the distribution is bimodal. And then I said caffeine content varies from 15 milligrams to 47 milligrams with an IQR of 10.5 milligrams. In this case, it's really unclear what I should use because I think technically, if we wanted to, we could say this distribution is symmetric, which means that range would be appropriate, which I have listed. But because it's bimodal, I'm not sure if range is the appropriate description. So everything that I think might be important, I included. Meaning, I said where the peaks were, I gave the range, I gave the IQR, and I'm hoping that that's going to be enough to cover, or to show, I should say, that I know how to describe a distribution, and I know what I'm looking for. The income of college grads echoes this house prices problem. So, income is typically right skewed. It's money, so it's typically right skewed. So I would expect the mean to be greater than the median. That means that 60,000 is probably the mean and 48,000 is probably the median. And that this statement, the mean being greater than the median, comes from this picture. Your median is going to be toward the center of this data, where most of the data is, and then the skew is going to pull your mean farther away from it. So, mean is going to be bigger. I'm not really going to talk through the math on this one, but yes, you can find the annual payroll, but you cannot find the annual payroll if all you know is the median, because the median describes a location. It is one part of the data. It's like the 5-number summary. It's just giving you locations in the data, and those locations matter, but it can't give us information about the values of the entire data set. Whereas this one, we don't know the values of the entire data set, but we can work backward and find the sum of all of the data values. What's the mean salary and the median salary of the accounting firm? Well, the mean salary is $270,000, but the median is $22,000. Income, right skewed. So this is a good concrete example of the mean being greater than the median because of that skew. So all of the employees but the firm's owner make less than the mean salary. An unethical recruiter could mislead prospective employees by telling them that the typical salary at the firm is $60,000, but that's not the typical salary. Prospective employees will think they're going to make more than they really will because excluding the CEO, the average salary is $30,000. So prospective employees will make closer to $30,000, not $60,000. This is an excellent example of why you are told to use median to describe a typical observation when they're skew instead of the mean. The mean will be much bigger than is accurate for the entire data set, so you rely on the median to be a better description. These past few problems, so 83, 84, and 85, are very reflective of what you should expect to see on a test. They're not only expecting you to recognize that skew makes the mean greater than the median, but they are asking you to apply it to a real-world situation. Or here, they're expecting you to recognize that the median is describing a location, and the mean is factoring in all the data values. So instead of just asking you a straightforward question on that, they're going to ask you a question with all this background information that you have to kind of pull apart and make sense of everything. And then our last one, without giving the description, what I can tell you is that they give you a lot of important information on this, and if you haven't been able to do this problem, I would use what I have written here as your guide. So even though they're not giving you exact values, they are giving you stems. They are giving you your minimum and your maximum. And using those things, you can find range. You can get a good idea of what the IQR is. You can describe a typical test score. So if you haven't done this yet, I would try to make sense of what I'm writing here and then write your description, which means you should pause. But if you did write it, I'm about to uncover my solution. So last problem, the distribution of exam scores is left skewed. There are no outliers. I did not mathematically calculate that because 1, I don't know the IQR, but 2, there's no gap. So because there's no gap, I feel confident there are no outliers. The median is on the upper 8 stem. So students typically scored between 85 and 89. So this is going back to a histogram. They've given it to you as a stem plot or a dot plot, and what you have is basically a histogram. This is telling you 2 students scored between 60 and 64. 2 students scored between 65 and 69, so on and so forth. So they're expecting you to read this stem plot that's missing the values as a histogram. So that would have been a better hint to give you as before I uncovered my description. That really, if you think about this as a histogram instead of a stem plot, you may be able to more easily describe the distribution. The scores vary from 64 to 95, and I know that because they tell us that in the prompt. And then I have the IQR is in the interval from 75 to 94. So I end with most students scored between 75 and 94. And if you go through and count how many students are have scored between 75 and 94, it's something like 21. So 21 out of 32 is most students. Most students are between 74 and 95. Not 65 and 95. Okay, so that's it. This idea of describing a distribution will 100% be on your actual AP exam. It will be a free response question. So you want to feel very, very confident about everything that you are seeing on this check for understanding. For your exam, you will describe a distribution, but it will be compare these 2 distributions. So I'm not going to just give you one graph and say describe this histogram. I'm going to give you two graphs and I'm going to say compare the distributions. If you can compare the distributions, then you can definitely describe the distributions. So hopefully that was helpful. That was a doozy. This assignment took me forever, even typing out the answers. So hopefully it didn't take you quite as long. All right. Love you guys. Miss you guys. Hope we get to be together soon.